We saw that systems of two linear equations in two variables can have three types of solution sets, depending upon the ways in which the lines are oriented in the Cartesian plane. If the lines have different slopes, then they must intersect at a single point, and the system will have a single unique solution. If the lines are distinct and parallel, then there are no points of intersection, and the system has no solutions. And if the lines are identical, the two graphs coincide, intersecting at an infinite number of points. The system therefore has an infinite number of solutions. Likewise, systems of three linear equations in three variables can have a single unique solution, no solutions, or an infinite number of solutions, depending on the ways in which the three planes are oriented. Let's consider all the possible ways in which three planes can intersect or not intersect. We will number these planes 1, 2, and 3. One possibility is that no two planes in the system are parallel, and all three planes intersect at only one point. In this case, the system will have one unique solution. A second possibility is that two of the planes are not parallel, and so their points of intersection form a line. If the third plane intersects the other two along this same line, then the common points of intersection for all three planes are represented by that line. The system will therefore have an infinite number of solutions corresponding to every point on the line. The third plane does not necessarily have to be distinct from both of the other planes. If the third plane is identical to one of the other two planes, then the points common to all three planes are still represented by the same line of intersection, and the system will have an infinite number of solutions. An infinite number of solutions will also exist if a system consists of three identical planes. In this case, any point which lies on one plane is common to all three planes. The system will therefore have an infinite number of solutions corresponding to every point on the plane. In addition, there are several orientations of the planes which will result in a system with no solutions. Anytime a system has two distinct parallel planes, there can be no solution. Since distinct parallel planes have no points in common, regardless of the orientation of the third plane, there can be no points which lie on all three planes. The third plane can be distinct and parallel to the other two, identical to one of the other two, or not parallel to either of the other planes, thus intersecting both planes. Regardless of the orientation of the third plane, since there are no points in common to all three planes, the system has no solutions. One additional configuration of the planes which will result in a system with no solutions is if the planes are oriented so that their intersection points lie along three distinct parallel lines. Once again, since there are no points in common to all three planes, the system has no solutions.